Here's another example of where you have to solve a system using substitution. If you look at the coefficients in the system, every variable has a coefficient, so you're going to have to decide whether it's better to solve for the top or bottom x or y. The way that I do that is I check the first coefficient, in this case -2, and I say, can -2 divide in my other two numbers here? Can -2 divide into 6 and give me an even number, or a whole number rather? Yeah, 6 divided by -2 is -3, and also the 6 over here, 6 divided by 2 is -3. So this is what I'm going to solve for. I'm going to solve my top equation for x. Now, when you're solving that top equation for x, and I'll do all the work over here, first thing you have to do is subtract 6y from each side. You're left with -2x equals -6y plus 6. Divide everything by -2, be careful of your signs, and x is going to equal 3y minus 3. So there's my x value. I can now take this bottom equation and rewrite it to finish the system. -7x plus 8y equals -5. At this point, we're actually to where we need to do some replacement. So I'm going to take my value for x, and I'm going to plug it into the bottom equation. Careful that there's a -7 there, so the -7 needs to stay. -7 times the quantity 3y minus 3 plus 8y equals -5. Start distributing the -7. -7 times 3y is -21y. -7 times -3 is +21. Carry down the plus 8y, and it equals -5. Combine like terms, -21y plus 8y is -13y plus 21 equals -5. Now we're at the point where we're doing a two-step equation. -13 equals -26. Divide each side by -13, and you'll get y equals +2. You now need to take that value, plug it back into the equation where you isolated x. So if x equals 3y minus 3, and you're plugging in 2 for y, 3 times 2 is 6. 6 minus 3 is 3. So there's your x value. As always, write your answer as an xy pair. The solution to this system of equations using substitution is 3, 2.